So today, last topic before the second test, I want to talk about something I call mixed analysis of variance. You'll hear people call a lot of things. Split plot is another term you sometimes hear. But this is basically going to be about combining a between measures approach or repeated measures approach and sort of within approach or repeated or a between measures or independent groups approach. So putting them both together. So far we've talked about simple between and within experiments. That's just a one-way analysis of variance either with repeated measures or not. And we've talked about factorial analyses, that's with more than one independent variable, both between and within. Right, so between subjects just means different subjects, different groups. Within subjects is everybody gets the same. Everybody gets all levels of an experiment. What about combinations? I now think of the little girl meme saying, why not both? So, let's do both. I'm pretty hip with 2014 references. I'm hip with the scene. I'm down with the street. My street name is Dave. Given to me by my parents. So, let's combine the two. That's all I'm saying. It's pretty simple. And I'm getting excited because, I've got a fake enjoyment of statistics. No, I actually do like it. You might ask why, and it's not just because this is something you might want to teach somebody, but it's actually a very, very common approach. You'll see this if you go to the thesis conference thing, which I encourage you to do, March 27th, I think. Go. See, I think it's biology in the morning and psychology in the afternoon, or reverse, I don't know which. But go, you'll see people doing things where they have an independent variable that's repeated and one that isn't. You might want more than one between or one within. Let's say species and learning, something I'm kind of interested in. So if I'm comparing two species, so learning we always have to have repeated measures, right? We've talked about that before. But if I'm going to compare two species, I can't use that as a repeated measures thing. I can't, say, well, now you're a chickadee, and later I will turn you into a dark-eyed junco. That's not a thing. I don't have those powers. If I did, you'd all be lining up on Sundays and worshiping me. So, by the way, in the game of civilization, you can create your own religion. My religion is always just called Dave, or Broadbeckianism. And it's great at converting cities to Broadbeckianism. All I think about is civilization. Anyway, what about sex differences, right? It's something I'm always interested in, right? So male-female differences in, say, learning, right? That's a thing. What about learning different tasks, a spatial task and a verbal task? Ooh, boy, we got all kinds of different things. So that's a 2 by 2 by 2, one between, or two between, one within. Woo! No. Two within, one between. So there's all kinds of possibilities here. And in fact, a lot of experiments involve having a repeated measure and a between subject factor. And of course, then the ubiquitous, etc. Okay, here's an example. We have two kinds of memory tests here. We have implicit memory and explicit memory. Implicit memory is I ask you to, first of all, what do? I give you a list of words. Okay? And then I either have you recall the words, that's explicit, or I have you fill in the blanks of the words. Or do stem completion, like the first three letters, and I leave some blank. And I compare those words to distractor ones, like ones you haven't seen. And in fact, you do better in ones you've just seen, and you may not even be aware that they were on the list. That's what's kind of cool about it. Take my memory class, second term next year, and learn all about it. Implicit and explicit memory. And we get retention intervals here, 5 minutes, 1 hour, 24 hours. This is not an uncommon approach in cognitive psychology. You may be concerned, though it turns out you shouldn't be concerned, but you may be concerned that the explicit test somehow contaminates the implicit test, and you want to just sort of to look at one thing in isolation. So you want to have one group do the explicit experiment, and one group do the implicit. Okay? Questions so far? All right. You still want a decay function, so you want to see if there is one. There won't be one with implicit, there will be one with explicit. So you want to see that, so you want to do repeated measures. So group 1 is the implicit, group 2 is the explicit. So the sources of variation here, and I'm just saying group 1 is subjects 1 to 10, group 2 is subjects 11 to 20. I'm just saying n equals 10. So the sources of variation here are test type, right? Implicit or explicit. That's one variable. A second variable is retention interval. 5 minutes, 1 hour, 24 hours. When we talk about repeated measures, when I was talking about subjects here, we can't talk about subjects here without mentioning where they are. So we say subjects nested in test type. That's how you read that. Subjects are nested in test type. Because you can't mention subjects without saying where they are. And it's not an interaction, really, because all subjects don't get all levels of test type. But subjects get one level or the other of test type. So subjects are nested within test type. Okay? All right. So we have analysis of variance summary table here that's actually not that hard to build. You start out with the between subject variable, which is test, or test type, whatever you want to call it. Okay? That's where you start. And then you list all your between subjects variables, then you talk about subjects. In this case, we have subjects within test. And then you then do your within subjects variables, retention interval. And then you cross it, look, retention interval by test, retention interval by subjects within test, done. This is called Yates order. This was developed. This way of presenting the variables is Frank Yates' idea. He was one of the people who started doing analysis of variables, along with Fisher. So, and then for what are the error terms? Test and subjects within test, retention interval by subjects within test, retention interval by test, retention interval by subjects within test. Degrees of freedom, there are two kinds of tests. So one, subjects within test, n minus 1, which is 9, because there are 10 subjects in each group. 10 minus 1 is 9, times 2 levels of test is 18. There's 3 levels of retention interval, so there's 2 degrees of freedom there, and then so on. The nice thing is when you do these things, the chance of you getting the degrees of freedom right and having done it wrong are pretty slim. So it's sort of a way to double check yourself, because there are 60 observations in that experiment. So that means there are a total of 59 degrees of freedom. And when we divide it up, we get these degrees of freedom here as we have in the table. And our total is 59. I would probably get it right. Questions so far? Please.
What was that part about the 18 again?
18, so there's 10 subjects in each group.
Yeah.
So 10 minus 1 is 9, n minus 1. Mm-hmm. And times 2 levels of test.
Okay.
That's all it is. So it's not the total number of subjects in the whole experiment. Because remember, it says subjects within test, so it's how many subjects are within each level of test, minus 1, times the number of levels of test. Okay? Mm-hmm. Make sense? Mm-hmm. Good. All right. So to review how to do this, you list your between subjects factors, then you list your subjects, and then you list your within subjects factors. And then as you go along, you do the interactions of each factor with everything above it. If you do that, you cannot make mistakes. It's very mechanical. The beautiful thing about this is it's completely mechanical. You can't do this incorrectly. It's beautiful. It just works always. And the error terms are easy to figure out because it's always the thing that's below the thing you're interested in that has subjects in it. Now this assumes everything is fixed and the subjects are random factors. And in fact, almost your whole life will work out that way. So you don't have to worry about it. And you know what? When they aren't, there are ways to find that out. And this isn't going to happen if you go to graduate school anyway. But a really good graduate level stats book will have a table of how to figure out expected values and mean squares in the back. And then you work out that. You know what else? You can just call somebody. Go find out who the stats person is, you know. When you're doing your work and say, I don't know how to do this. And they can help you. And if you've seen a YouTube video of me showing you how to do a repeated measure design, you actually have to do the calculation yourself. You actually have to get out a calculator and divide one mean squared by the other. Well, if you don't know, but again, that's if one's fixed and subjects are random. But that's going to be the case probably for your whole life if you go on and do anything like this. Okay, here's another example. This is, we have 5 subjects per group, and I've got, I'm not going to tell you. All I can tell you is I've got, 3 levels of B, 2 levels of C, and 2 levels of A. What are our between subject variables in A? That's how you start it. Let's figure out what the betweens are. Which one is a between subject factor? Or which one's? Look at it this way. Which one, the different subjects get different levels of that factor? So let's look at A. The different subjects get different levels of A. It's a simple question. It's a yes or no question. Yeah, they do, right? A1, group 1 gets A1, and group 2 gets A2. A is a between subjects factor. Okay, what about B? The different subjects get B1, B2, and B3. Everybody gets B1, everybody gets B2, everybody gets B3. And I think it's the same with C, right? Yeah, everybody gets C1, everybody gets C2. So those are within subject factors. So A is a between subject factor. B and C are within subject factors in this case. And over there. So between subjects within, between is A, within are B and C. And these are supposed to be arrows, but I didn't feel like pulling the little drawing thing tool down and making arrows, so I did a minus and A greater than. So. Okay, so A is a between, B and C are within. Does that make sense? Because different subjects get different levels of A, but everybody gets every level of B, and everybody gets every level of C. Okay? All right. I don't know how I'm going to teach a 3-hour class next year. I really don't. Anyway. I'm old. I can't stay on my feet this long. I'm turning 55 this year. I'm going to be able to get the see. I think I can get some seniors discounts now. I'm pretty excited about that. It's starting to be the case that I'm older than my students' parents. That's weird to me. In like 1990, what was that? No, in 2001, I was teaching in Newfoundland. I was teaching intro psych, and they were all 18. And I was 36, and I stopped in the middle of class and went, "Oh my God, I'm twice your age." Now I'm older than your parents. Anyway, whoa, look at that. Actually, A is between, B and C are within. This isn't actually that hard. It looks ugly. I think it looks beautiful. But it looks complicated, but it's not that bad. Let's not worry about degrees of freedom yet. Let's just get the terms right. So we've got A. It's the only between subject factor. It's the only one. So we list it, and now we list the subjects. And they have to be within A. Because it's the between subjects factor. So A, subjects within A. And now I did C next. I don't know why. I could have done B next. But I'm sticking it to the man by doing C instead of B. I don't know what the hell I was doing. Why not? C, C by A, C by S within A. Done. B, B by A, B by S within A, B by C by A, B by C by S within A. Done. It's mechanical. It's very mechanical. As for the degrees of freedom, we take a look. There's 2 levels of A. We have, what did I say N was? 2, so it's 5, right? Was that written anywhere? It must be. Yes, it must be. So, 4, N minus 1, times 2 levels of A is 8. These are pretty simple. Oh, then let's just go from there, okay? Let's just go from there. And then, what do you test with what? When you do, we actually did the analysis of variance with mean squared A divided by mean squared for S within A. Mean squared for C, mean squared by S by C within A. Mean squared for C by A, etc. Okay? That's all you do. And you're just, again, you're probably wondering, why am I worried about this? Because, well, there's a couple reasons. First of all, if you don't have software that can do repeated measures easily, you're going to have to do it this way and list out each subject, each score as a different row. Just like it's in that YouTube video that I have on my website and both on my blog and on the podcast blog. It's on both places. So you might have to do it that way anyway. Secondly, when you go to do an analysis, one of the nice things that computers have done is they've made doing data analysis easy. You don't have to do this shit by hand. You know what the bad part is? It's too easy. So it's so easy that you can do it wrong and it still gives you an answer. So when you, before you analyze your data, or when you're reading a damn paper even, just look at the design and say, okay, they're using ANOVA good. I'm just going to break it down and see what the mean square should look like. Because you know what? Sometimes people do it wrong. I have actually, when reviewing manuscripts for journals, when it's an analysis of variance they're using, I draw the, well, I do this all the time anyway, I draw the design in for myself, just like you with A's and B's and C's and the groups, I do that. And then I say, okay, how would you do this? And then I take a look, and about 1 time out of 10, I catch someone making a mistake. They aren't doing it to, cheat. People do things wrong. So it allows me as a reviewer to say, oh, you did that one wrong. You might want to redo that. In fact, if you don't redo it, you're going to make an idiot of yourself. Right? So people make mistakes. So if you can catch you making mistakes, you correct stuff. But also, it's so easy to do an analysis and get some numbers when you're doing it yourself. Sometimes you want to double check it just by doing it, doing this step at least by hand. Let's do one more. Whoa, this was complicated. It looks the same, except when you look a little more closely at it. What are the between subjects factors here? What are they? There's just 2. Now I'm getting into hints. There's 2 between subjects factors. What are they? Yes, thank you. How do you know? Because different subjects get different levels of A and different levels of B. What about C? Everybody gets every level of C, don't they? Okay, so now we have 2 betweens and 1 within. We've just changed the experiment a little bit. Subjects are now nested within A-B interactions. They aren't just nested within A or within B, they're nested within A-B interactions. Right? Look, because you got G1 is in A1, B1, G2 is in A1, B2, etc. So they're within A-B interactions. Okay. And I hear I said there's 6 per group. And we've got what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 6, 72. There are 72 observations, should be 71 degrees of freedom. Let's do this one. A, B, doesn't matter, you can do B, A, I just did A. A, B, A by B, S within A, B. And then C, etc. And I cross them. And you can see what the test was what by just taking a look and seeing what's below this that has it. So A and subjects. Oh, that would be the error term for A. So all you have to do is just to remember between subjects within. That Yates order thing. If you can remember that, then you can always do this problem. I can tell you that about 37.5% of the marks on the final exam are doing these things. Right? I think that's the correct term. And they're actually easy to use by practice. All right. Questions? Before we move on, I have some questions for review for. Okay.